Okay, name.
We are the coordinating cat dragons. So our mission statement is we are creating a drone that, unlike most teams, is underground, and it's supposed to unclog and temporarily repair oil and gas pipelines.
Your team, one team?
Yes, one team.
What our drone is going to do is it's going to be underground around the pipe, oil or gas pipe. Whenever it's going to have a 3D printer, a heat sensor, and a thermal imaging sensor connected to the drone. While it's going down the pipeline, if it sees a crack, it's gonna have the 3D printer print the
Space over
the crack. But if it's a clog, the heat sensor is gonna heat up the clog, and while that's happening, the 3D printer is gonna space it out.
Our problems are, what we were saying, oil spills, oil clogs, and faults in pipelines, and our solution is our 3D printer, a heating system, which uses radiated heat waves to unclog the pipeline, and a scanner or sensors that will see the depth and heat and all that stuff.
And for the actual skybout competition, for the obstacle course part, our plan is to start near the hexagon, in which we'll go through the hexagon, through the square, and then through the triangle. And then we'll land here and do it over again.
The reason for taking that flight plan is because we think that going through the hexagon and the square first would score us the most points, and in our opinion are the easiest obstacles to get through, and that leaves us more time to get through the triangle and get to the landing area and redo it.
As if Sean was talking about the obstacles, during the times out, our pilot Marcus and our co-pilot Sean have been working on the drone. They've been going through the square and the hexagon more easier, but when they were going through the triangle, they kind of had some harsh times because you had to fly at the right angle to go through.
Me and Cody are doing the autonomous part of the competition, and we are using JavaScript to program the drone, in which we have to make a script, and then we basically just press enter, and it does what it does.
So talking about the script, what we had to do is, as Mr. All, our programming helper, what's happening is once we have the script done, what we have to do type in is node space calibrate 2-3 whatever script we have, and then after that we press enter when the drone is connected. But the drone is not connected through a Bluetooth or a wired. It's connected through Wi-Fi, so it's basically like connecting to a Wi-Fi to go on the internet. It's basically connecting by that. You can control it on your phone or on the computer too.
So for the sprint course, I'll be piloting the obstacle. We'll be switching. So Sean will be piloting the sprint course because he has been flying better through the obstacle and that through our tests.
We're both pretty good at both, but we have our strengths and weaknesses on both the sprint course and the obstacle course.
Sometimes when they're flying, sometimes they do good, and sometimes they have some little bit difficult times flying.
In our engineering journal,
Yay!
first thing we actually we didn't have too much. We only have a couple pages because this kind of started towards the end of the year, and unlike our engineering journal for robotics in general, we don't really talk about what we do on a daily basis. So most of it is kind of notes on what we have to do for the Skybot competition and for our business plan. So we have our Skybot pilot training, we have our Skybot pilot training and all that, and what we have to do then we have like notes in general of like dates and what we have to do, like stuff like this. And that's about it. And then we have some notes on like what we're going to do for this.
Did you put anything down for what you learned or strengths that you, knowledge learned?
Not yet. Most of that is just
Trial and error kind of.
Yeah.
How did you know to bring that today? What did they, was that part of the?
well, I think Mr. Patrick told us.
Yeah, especially when it's a Skybot
And
challenge.
then we kind of knew that because we're in Vex, and in Vex, during every competition, we have to bring an
Yeah,
engineering.
right.
So we kind of got used to bringing things like that.
So how many versions of your autonomous program did you have to write before you ended up getting something that worked well?
We all, like, it was kind of like guessing during the autonomous because you don't really know, like, exact calculations because, well, you kind of do, but you kind of don't because sometimes if you can do this one script one time and it'll end up in one spot, you do it the other time and it'll end up maybe like a feet or two away. So,
Different air currents on that flight
Yeah.
or whatever, right?
yeah, but most of the time we've been testing it out like in groups during every period with Mr. Al and Mr. Tim.
So when Mr. Al was talking with us, first I was like, I didn't really know what to do. So when he showed me the PowerPoint that he had set up, what it was is basically the commands like forward, back, up, down, left, right. When we got to that, I was like making sure there's like we had to put the speed on